we're going to go over some definitions of periodic functions. So we talked about before putting everything in radians. So we can see that this one crosses 0, 0, so we know that this is actually y is equal to sine theta. In both of these, they've actually done that. The period of a function is essentially how long it takes for that function to get to start repeating its pattern. So with sine, it's very common to look at sine and think of it as starting at 0, 0, going up, crossing back down, going down, and coming back up. Now, it can get confusing because at this point, you're actually at the same part you started, right? We start at 0, 0, and then at pi over 2, 0, you're at the same y-coordinate. But the problem is, if you just look a little before 0, you're actually heading in an upwards trajectory where you're heading from the negative to the positive to get to 0. But when you get to pi over 2, you're actually heading from the positive to the negative. So that's not a full period. It's when we start heading back up again that we consider this an entire period. And at this point, we're at pi and 0. So what that means is the period is equal to pi, which, if you remember our unit circle, that's getting around halfway around the circle, which is also the equivalent of 180 degrees. Okay, so that's all a period is. How long does it take? You could ask the exact same question with cos theta, and you'll notice that this one is a little easier to measure that because we start at a peak, we go down to a trough or a low point, and we come back to the peak. And for that to happen, it's at 0 and 90, and then at pi and 90. So that one's a little easier to see the period. And you'll notice the period is the exact same between both of them. A period is actually pi in terms of how long it takes to get there. Oh, it's kind of off screen for you there. Let me recenter this so you can see it. There we go. It's a little recentered. Okay. The principal axis, as a definition, that just is where is the middle. So for sine, it's actually really easy to see where the middle of it is. We're looking for the average between the high point and the low point, and traditionally that's really at 0. When we write just sine x, it's where y is equal to 0 would be your principal axis, and that same thing happens with cos. Cos's principal axis is also right at 0. Y is equal to 0. It's the middle. When you start doing transformations, you'll notice that these functions, they don't have to actually be in their traditional spots. We can put more values in, and then they'll start to occur at higher and lower points. What you want to do to find a principal axis is you want to find the peak, so the highest point, let's say that's 5, and let's say the lowest point is 3, and you'll find the average. Average between the max and the min. So you can actually say max minus min divided by 2. And that will always get you your principal average. So for instance, in this case, I just gave 5 minus 3. I said that right? Sorry, plus, not minus, plus. 5 plus 3 gives you 8 over 2, which means 4. And that would make sense. In between 5 and 3 is the number 4. So max plus min divided by 2 will get you your principal axis. Okay. Amplitude, on the other hand, your amplitude, that was the equation I had, is asking for the distance between the principal axis and the highest point or the lowest point. And that also becomes important. It's usually known as the A value when we're starting to do transformations. But in order to find that one, you take the max minus the min and divide by 2. So with the same concept here, where we have a max minus min, 5 minus 3 divided by 2 is 2 divide 2. The amplitude is 1. And that actually makes sense as an amplitude. If we go to the middle, the distance to get to the top is 1 unit. And then from the middle, the distance to get to the bottom is 1 unit. It should be the same. If it's not the same, that means you actually haven't found the correct middle of the periodic function. Okay, so these are our little formulas: max minus min divided by 2, max plus min divided by 2, and whatever the cycle is. Okay, these are little formulas that can help you in terms of always finding the period, the principal axis, and the amplitude of any periodic function. So keep those in mind. They're going to be very important for what you're going to be delving into next in the course.